today let's get started with the last tool in our course, which is monitoring tool called Prometheus. So first, let us understand what is a monitoring tool. Why do we need a monitoring tool? If I'm not audible, please let me know. My voice may be low. Please let me know if you can't hear me. So why do we need a monitoring? Like we discussed earlier also, if your infrastructure is very small, let's say you have 4 servers, okay, or 5 servers, right? You want to know the status of those servers, right? Health of those servers, the resource utilization of the servers, like CPU, memory, right? The disk space available, all these resources, at least the uh, basic resources, you can monitor manually, right? If the infrastructure is small, let's say we have just 4 servers, 5 servers, you can do this. But what if your infrastructure is having some thousands of virtual machines or huge infrastructure, number of applications? How do you monitor their health, right? This is very important to monitor their status, their health checks, their resource utilization, their disk space available. If it is an application, you want to know mm, the input request for the application, how much load the application can take, what are the errors that we are getting with the application. All of that should be monitored, right? Particularly for a DevOps approach where we have completed our CI/CD by now, right? We have integrated so many tools, we have completed the CI/CD pipeline. But we should also integrate a monitoring observability, correct? Like we should know the server status, the application status, and all. That's where comes monitoring tools into picture. There are hundreds of monitoring tools, each has their own pros and cons. Prometheus is very famous and widely used. Nowadays, it's the first option, particularly for container-centric applications, where your applications are deployed as containers. Prometheus is the best choice. So we will be talking about Prometheus here. It can monitor any infrastructure. We can also see monitoring is very important, and once it monitors, it should also send the alerts. That's the next important part. It's not just it monitors and keep it, right? It should alert the teams, alert the right teams with the right message. And that's where Prometheus comes in, which can provide you with alerts as well. And another important thing about monitoring is it not only just monitors or informs you when the actual problem comes in. Let's say, okay, the disk space is 100%. It's not that it will inform you. You can also put the alerts in such a way that it will inform you when it is 80% itself, right? So that means it is informing you beforehand so that you can take some steps, see that the disk space is not completed and the system would not be crashed. So you can set the warnings apart from the actual alert. You can also configure the warnings so that you jump in to see the actual issue and fix it before the actual problem comes in. Right? That's what Prometheus does. Prometheus is one of the monitoring tools. There were so many tools like ELK, Splunk, Nagios, and so on. So many. Prometheus is one such tool which is good at monitoring this. So Prometheus is a monitoring tool. It has also got the default dashboard, the basic dashboard it has got. Right? To have better visualization or to have custom reports, we have a great visualization tool called Grafana. Grafana is actually a visualization tool. It's not a monitoring tool where you need to have a good clarity on it. It's not a monitoring tool. It's a visualization tool where you can visualize the data in Grafana. Right? It provides a good dashboard, good charts, custom charts can be prepared here. Okay, we'll look into that. So let's begin with the Prometheus architecture of Prometheus. Then how do you integrate Prometheus with Grafana? We'll see. See, Grafana, you can integrate it with so many other tools, not only Prometheus. You can integrate it with ELK, you can integrate it with the Splunk, you can integrate with different database, so many, right? You can integrate with, and it still can serve as a visualization tool for those monitoring sites as well. So to understand better, let's get into the architecture of Prometheus. Here is the architectural diagram for Prometheus. Yeah. So actually, this is a Prometheus server. Prometheus server should be a Linux machine. Okay, any Linux is fine. Any version of any distribution of Linux is fine, but it should be a Linux server where you will install Prometheus. And once you install Prometheus, these are the different components it has got. First one is the data retrieval, storage, and the web server. Right, these are the three components you get to install with Prometheus. And the first one is a data retrieval worker. What is this data retrieval worker? See, to understand this, you need to understand things like in Prometheus, it works with a pull configuration. Many other monitoring tools work with a push configuration, means they'll push the data, they'll push the metrics. What is a metric, by the way? Metric is the unit of measurement, means metric is the unit of measurement. Like, let's suppose we want to measure the memory utilization, memory consumption. That's a metric. CPU utilization, that is a metric. Or else I want to check the disk space, that is a metric. I want to check the service status, that's another metric. So the units of measurement, or else the entities which you measure are called metrics. And majority of the monitoring tools will push the metrics. Means they'll push the metrics, which becomes the overhead to the server. But here Prometheus will pull the metrics. Give me a second, please. So Prometheus will pull the metrics from different targets. How this pull works, we'll discuss. So basically, it works with a pull mechanism. It pulls the metrics from the different resources. So this will pull the metrics, and there is a component called data retrieval worker, which will help in this pull. That's the first thing. Once data retrieval pull the metrics, all these metrics will be stored in another local database, and it's a time series database where data will be stored with a timestamp. That's a TSDB database that's called as TSDB server, where all the data will be stored with a timestamp. And Prometheus has got a GUI, the basic dashboard. So here, if you want to see any metric, you can write some queries, which uses PromQL. PromQL means Prometheus query language. I'm sorry. So using this, you can write some queries. You can trigger some queries on the GUI. Depending on the query you write, it will fetch the data from the data's TSDB server, like time series database, and show it on this GUI. And this GUI runs on the web server. That's what is the third component, HTTPD web server. So this is the basic components or architecture of Prometheus. Data retrieval worker will retrieve or will pull the data from different targets and store them in a time series database with a timestamp. And they will be fetched via this HTTPD web server when you trigger a query from the web UI. This is the basic architecture of how Prometheus works. It works with a full configuration, but there might be some jobs, like very short-lived jobs, means a small job which would be terminating in 2 minutes. So full may not be possible. Their push configuration has to be implemented. Even that is possible through something called push gateway wherever required. But the actual way how configurations are, how metrics are gathered is through pull in Prometheus. Any questions in this part from anyone? Okay, so now that we understood the architecture, let me talk about this full configuration in more detail. Suppose there is a server, there is a remote server. Okay, from this server, Prometheus has to pull the metrics. This is Prometheus server, which has to pull the metrics from here. It will pull the metrics from here. For Prometheus to pull the metrics, first of all, this server should expose the metrics to an endpoint. Means it should show the metrics to an endpoint or a URL or a port number, whatever you say. This particular server should expose its metrics to an endpoint or a URL or a port number. From that endpoint, Prometheus will pull the metrics, right? Certain targets can expose these metrics by default. Means it is exposing to an endpoint or a port number, and it was exposing in a way Prometheus can understand. So some of the targets can do it by default, but in case if the targets cannot expose, or else for certain targets, for making them possible to expose the metrics to an endpoint, we have to install something called exporters. Exporters are like add-ons or a software which you have to install on the target machines, which makes them to expose their metrics to an endpoint or a URL or a port number, from where Prometheus can scrape the metrics at regular intervals. You can define at what intervals it has to scrape or pull the metrics. That is the basic concept you have to understand. Means, let's say there is a Linux server, you want to monitor its resources. You have to install a metric, you have to install something called exporter on this server, right? A node exporter maybe, which can scrape the metrics. Understood, everyone? Got it? So now let us install Prometheus and see how it can monitor or pull the metrics. Prometheus can be installed different ways. You may take up a Linux server like any other EC2 instance, install Prometheus like you install any tool and do it. Or else we can install it in a whole different way today. We shall install it in a different way through a Docker container. You can also access any service as a Docker container, right? So let us try doing it. Anyway, we need a machine to get started. I'll use a new machine. Let me terminate the unused instances. Okay, let's start a new instance. I would like to name this as Prometheus server, where I'm going to deploy Prometheus as a container. So this is an instance. Now, in this instance, I would like to start Prometheus as a container, also Grafana as a container. So I would like to start two containers, one for Prometheus and Grafana. And also I would like to start some other DB container also for monitoring. So total 3 containers I have to start. So what is the best way if we want to start multiple containers together? Which tool I can use? Yes.
Docker Compose.
Docker Compose. So I would like to install Docker Compose here. Docker and Docker Compose so that I can start all these containers together in one go. Okay, so let us install Docker and Docker Compose. And then install Docker Compose. We have seen how to install Docker Compose, right? Download the binary and provide executable permissions for the binary. Okay. Now we need a Docker Compose file, right? We need to write a file. So let me create a directory called Compose. Go into this directory and create the Compose file. Docker compose.yml. So here we can define Prometheus, Grafana, some DB container. I'm going to use Redis as a DB container. See, I'm going to start all these containers here. Prometheus, Grafana, Redis database container, and also another container called CA Advisor. What is the CA Advisor? CA Advisor is nothing but a container which can collect the resources or metrics from other containers. Means it is a service which can help you grab the resources or the metrics from other containers. So this can grab all the resources, your metrics from all other three containers. So I'm also going to start this. So here is a Docker file. This Docker file with all these containers is also, I mean, not Docker file, Docker Compose file is also available in the official website. See here, this is available in the Prometheus.io official website. Prometheus image, container name. Prometheus by default runs on port 9090. That's a default port of Prometheus. You can forward it to any port. I would like to place it on the same port, let's say 9090. And for Prometheus to run, you have to provide a file called prometheus.yml. Okay, that's a config file you have to pass when you run a Prometheus. So we are passing that to config file. This file I would like to place it in HC Prometheus of the container. So how does it go to HC Prometheus of the container? From our location, we are going to pass this prometheus.yml. To make it more clear, see, this is your container, right? This is your going to be the Prometheus container. See, this is your Prometheus container. In this Prometheus container, this is the folder Prometheus. Here you should put that prometheus.yml. Okay. So here that YAML file should be present. So how are you passing it? This is the volume. Got it now? Which is inside the container and which is outside the container. Right? So that's the first one. And that is depending on CA Advisor because CA Advisor should be started first, which will grab the metrics. See, that is coming from official GCR Google Container Registry. Okay, which is running on port 8080. These are the default volumes. We don't need to understand this. These are the volumes required for that CA Advisor. And here comes Redis. Name is Redis and the port is 6379 Grafana. Grafana default port is 3000. So total 4 containers would be started. All of them, Prometheus is dependent on CA Advisor. CA Advisor is dependent on Redis. So in which order these containers will be started? Can you tell me? First, which container will be started? As per this YAML file. Correct? This is the order in which those containers will be started. Am I correct? Because see, first Redis is not dependent on anything, but CA advisor is dependent on Redis. So first Redis, then CA advisor. Prometheus is dependent on CA advisor. So after CA advisor, Prometheus, and then Grafana. So this is how they should be started. But for Prometheus to work, we need to provide that Prometheus.yml. It should be in the same directory because I have given dot Prometheus. So let's create this Prometheus.yml. And what should be present in here? It will have the global configurations like the scrape interval, scrape configs, etc. Means, see here, global scrape interval every 15 seconds. I told you, right? Prometheus will pull the metrics. So at what intervals it should pull? These are the 15 seconds. And what is the job? It is going to pull the metrics from CA advisor container every 5 seconds. And the target is service name and the port number of CA advisor. You can add any number of targets like this. Can I run this? Can I save this file? Any questions with the Prometheus file or Compose file?
No.
Let us apply. Let us start. See, here are the file. This file will be copied into this Prometheus volume. So let us run docker compose up -d because I'm running from the same location. First, it was creating network, or everything will be prefixed with this folder name. See, first Redis is being started like we discussed. Then CA advisor should be started. Then Prometheus. See, CA advisor. Then Prometheus. See, Prometheus. Then Grafana. Grafana has been started. Grafana, Redis, CA advisor, Prometheus. 4 containers were started. So if you see here, Docker PS, Prometheus, CA advisor, all of them were running. Okay, if you want to see, go inside Prometheus. Docker execute -it win bash. It's saying no bin bash, maybe shell may be there. Yes. Okay. So where did we copy? Let's see Prometheus folder. Yeah. Prometheus.yml, which we have created. This is required for Prometheus to start. Done. Okay, fine. Prometheus is forwarded to port 9090. Let's see. Prometheus is forwarded to 9090. Open the ports, right? Security. We need port 8080. System TCP. Port 8080 where you have CA advisor. And port 9090 where you have Prometheus. And port 3000 per Grafana. Right? Done now. Yes, do you see Prometheus time series collection? This is the basic dashboard of Prometheus. Okay, that's a default dashboard of Prometheus. And this is what is the metric metric explorer. This is called metric explorer or metric browser. Here, if you click this, open metrics explorer. See, these are all the metrics. It was monitoring its own server, means on the server which is was installed by default. Up, you can select any metrics, execute, save one. Oh, sorry, it was not monitoring its own server. It was monitoring whatever targets we have configured. If you remember, we have configured one target, right? See, this is important. Target, CA advisor. So it will monitor metrics of that target. These are all the metrics of that target. Let's say container last seen information. Select execute. It's not showing anything. Let me choose. See, you have to choose properly. This is nothing but your PromQL browser. Maybe all this data is not yet summarized. One second. Right? CA advisors information, CA advisor container. Okay, there's one thing. And if you go to status, target, see the target, you have one target, and this is this target. Prometheus is pulling metrics from this target. I told you, right? For Prometheus to pull, the target has to expose the metrics to an endpoint. This is the endpoint which it has exposed to. Give me a second. This is the endpoint CA advisor has exposed the metrics to. Here, what you have to do, put the IP address of your instance. Okay, it was exposing to this endpoint or the URL. IP address :8080/metrics. See, these are all the metrics it was exposing. From this endpoint, Prometheus is pulling them. See, if you want, let's go back again to the metrics explorer. Here, whatever you see, all these metrics being exposed there. Let's say copy something. Scrape series edit. Okay, you are having something here. Scrape error, container scrape errors, machine scrape error, scrape error gauge. See, the same attribute may not be available, but if you see here, these are all the metrics you have, right? And every metric, let's say container scrape error is 0. There will be something called help, which explains what this metric is. Container spec CPU period of the container. Right, it can help you understand what this metric is. Also which type of metric is gauge type of metric, different types of metrics were there, right? So it can help you understand the metrics. Whatever it was exposing, those were being visualized here in this dashboard, right? So here are the targets, and whatever Prometheus.yml you have written, that will be seen here. Say scrape interval, other intervals I didn't put means default ones were considered, and the target, right? We have explained, we have configured few of them, like scrape interval, right? And this part. So whatever you put in Prometheus.yml can be seen here, and the targets here. Got it, everyone? Any questions? This is Prometheus and this is CA advisor. Here, let me remove this endpoint. On 8080 CA advisor, do you see that? Right? This is the CA advisor is nothing but a service which will collect the metrics from all other containers. Like what are all the containers it has got? See here, go to Docker containers. Yeah, red is Prometheus-Grafana CA advisor you have, right? You can see all of them here. Red is Prometheus-Grafana CA advisor. Yeah, driver status and all. And if you go to, let's say, go to Redis, any one of the container, if you go, yeah, CPU consumption, right? Memory utilization, and in the graphical format, in the chart format, all of this is provided by CA Advisor. CA Advisor itself will collect the metrics. From the CA Advisor, Prometheus is graphing those metrics, right? Like if you want to see, we have seen that is Prometheus container metrics also it was showing, right? So on 8080, you have CA Advisor, which does all of this kind of metrics collection. And now let's say, okay, this is a basic dashboard we have. If we want to have a better visualization, we can have Grafana. We are also running Grafana container. It's on port 3000, right? So let's get to port 3000. Right, it will ask for some username and password. The default credentials would be admin and admin. If we want, we can set a new password. I'm skipping it for now. It provides a beautiful visualization. Here under connections, you can add the data sources. Data source means with which it has to integrate. Here I want this to integrate. See, these are all the things it can integrate with. Google Analytics, Amazon Timestream, Redshift, Apache Cassandra, Azure DevOps, so many things. Right, you can see here. It can integrate with Dynatrace, another monitoring tool. It can integrate with Datadog and so on, so many. Right? See, New Relic, MySQL, MongoDB, Microsoft SQL Server, PagerDuty, PostgreSQL, Prometheus. We need this. So select this. You have to provide the required configurations. Grafana ships with built-in support for Prometheus open source service monitoring system and time series database. Add the new data source for Prometheus. So that's a name. Here you have to put the URL of the Prometheus, which it has to integrate. Okay, that's all. And save and test the connection. See, it has, you can start to visualize the data by building a dashboard. Done. So it's added as a data source. Data sources. This is the data source got added. Now you can create the dashboards. If you go to the home page, here you will see something like dashboards. General, no dashboards were there. Right? You can create a dashboard, new dashboard, add visualization. Prometheus as a data source. See here. This is how you will see the query tab where you can, this is your data source. Now, whatever you are querying here, the same way you can query here. It will connect to the same process. All of that we have seen, right? In that Explorer also, same things you will see. Say script series up and run the query. See, you can see here in the form of chart. And whether you want to see it in the form of chart or a pie chart or else different ways were here. See, you want to see that time series, time based or bar chart kind of. See, or else you want to see it as a stat. Yeah, different varieties, visualizations possible. I have given up, right? Up means one target is up. CA advises the target, it's up. But let me choose some other metric. Let's say some CPU container FS count. Let me choose some metric which we can visualize it better. See, it is asking, you can also open here. In the small thing, if you can't visualize, You can also select here. Let's say I want to see this. You can select here, run the query. It is also not having any data. Memory stats bytes. Let me choose this. Okay, so it's a bar graph type of chart. If you want time series kind of, see this is the graph. Do you see? As per the timestamp, 7:59:15. This was the graph. 7:81, then 8:3. You can see as per the timestamp. Can you all notice it? The graph as per the timestamp. See, it was showing. See here, I have changed this timestamp from this part to this. You can analyze, expand it this way. Right, I have chosen that particular time frame. I want to see from here till here. Drag it over there. Where is the graph? Yeah, see here because it changed. Or else last 5 minutes graph if you want to see. Last 15 minutes graph. Last 30-minute graph. Last 6 hours graph. You can customize accordingly. Right? Also, not only time series, I just want to see in the form of bar chart. See? Or else in the form of stats. In the form of gauze. You have different formats you want to visualize, right? Let's say I just want to go with the time series because that suits here. And I can apply and I can also save this dashboard. Like come here and save it. It will ask for some dashboard name. Let's say dashboard 1. Okay, that will be saved. See, you can put anything, any metrics. Means see, there might be hundreds of metrics, but you don't need to monitor all the 100 metrics, right? Whichever you want, you can monitor them. So let's say I want another metric. You can again see, add a panel, add visualization. This time I would like to choose read seconds total. And I would like to see it in the bar chart. Actually, there's nothing much there. Run the query. Yes. Time series graph. See, this is the graph. Okay. So I would like to see this as well. Save it. Okay. Save that. Save the dashboard. Within the same dashboard, I can save multiple metrics. Following. So also I can just arrange them like how I want it to be. If you want, you can edit or you can save it. I already saved it. So what happens? Save the dashboard. Okay, done. Now if you go to home, go to dashboards. Earlier dashboards were empty, but now in the general folder, I have this. Whatever metrics you want to monitor, let's say 2 metrics or 3 metrics, you can create panels this way and arrange your dashboard. So quick monitoring. Any questions? We will look into other parts of Grafana a little later. But is this much clear for now? So this is the Prometheus dashboard and the Grafana dashboard. Any questions from anyone? We decompose. So here is the Prometheus file. Okay, here is the Prometheus YAML file. Now I have only one target. What if I want to add multiple, another target? Let's say we have our Jenkins server, right? Let's suppose I want to monitor something with this Jenkins. This is the one, correct? So, yeah. Let me launch. Let me start it. So let's start Jenkins service. Meanwhile, let's launch this. Okay. So here, let's say my Prometheus want to monitor this Jenkins. For anything, it will pull the metrics. But for Prometheus to pull the metrics, this Jenkins should expose the metrics to an endpoint, right? So for that, you can, for this Jenkins to expose the metrics to an endpoint, you can configure the Prometheus endpoint, means to which endpoint it should expose the metrics. You can configure that endpoint here in a section called Prometheus. But it's not there because you will get that attributes or those options with a plugin. Once you install the plugin, Jenkins can expose its metrics to an endpoint. So let us install that plugin. Go to plugins, available plugins, search for Prometheus plugin. See, this is the one. Prometheus metrics. Jenkins Prometheus metrics expose an endpoint with metrics where a Prometheus server can scrap. Got it now what I'm saying? This plugin will help Jenkins expose its metrics to an endpoint, and from that endpoint, Prometheus can scrape the metrics. Doesn't support dynamic loading. Jenkins restart needs. See, that's what some plugins may need restart. So we restart your Jenkins. Let it start. Okay, now that is installed, if you go to manage Jenkins system, now here we should see a section for Prometheus. Yes, right. So here you can configure some endpoint. Default endpoint it is considering as Prometheus, that is also fine. and save it. Means what it does, Jenkins will expose its own metrics to this endpoint from which Prometheus can scrap. See, it can expose metrics something like job count. Do you see? Job count dot value. How many jobs? Job count value 20. Do we have 20 jobs? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Job count value is 20. From where is this 20 coming up? Maybe within this pipeline, these were also considered. Or else, do we have any multi-branch here? Yeah. Yeah, these were all considered. These ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So many are there. Let us do one thing. I'll delete this multi-job. Delete. Okay. So we should see a change in the job count. Let's wait. It will take some time to update, but we should see the change. It should not be 20. At least some change should be there, right? So let's wait. Let's wait till it updates. Okay, that's one thing. So it was scraping. Now Prometheus has to scrape, it was exposing. Prometheus has to scrape the metrics. Let's see. Was it added to Prometheus? Why, how to add the target now? If I want to add that Prometheus as a new target, what should we do? Yes. What should we do? You have to go to the Prometheus server and like we added CAD was one target, we have to add another target as Jenkins, correct? So let us try to do that. So this one. Now I would like to add one more target. It should be added as another job. See, this is one job. So let me add one more job. Job name is Jenkins. Metrics path. You can also put the path where it was exposed because you might have changed the path. If not, this would be the default path. So put the endpoint. Also static configs from where it has to grab. Then comes something called targets. And that we can put here itself. The IP address of the instance and the port number where it is exposed, 8080, right? IP address of the Jenkins server. Let's get that IP of the Jenkins. This is the IP. Now if you go here, right? Understood, everyone? Any questions here? So I added a new target, which is going to be the Jenkins endpoint. Now, this new file should be added to the volume, right? What you have to do is first stop other containers and start them again because it should update the volume. So Docker compose down, it will terminate all the containers, and then Docker compose up -c. I'm starting all over again. So see the containers now, Docker PS. Yes, container started a new container. So if you refresh it, sorry, Prometheus. If you refresh it, so if you go to targets, see new target added. Got it. Also, job count might have been updated by now. Yeah. See, do you see job count now? 11 jobs were there in this multi-branch. So when I deleted it, those 11 were gone, now 9. Can you all see that? Right? It was exposing, and this is pulling the metrics. Now it goes to Prometheus. Here in the metric explorer, I can see all the metrics about Jenkins. Do you see that? So let's see the job count itself. Whichever it is exposing to that endpoint can be seen here. The job count value, execute. See the same value which it was exposing here can be seen here. Interesting, isn't it? That's how all the Jenkins things can be monitored. Jenkins status, Jenkins server is up or not, right? Let's see everything related to Jenkins. Yeah. Executor counts, free history, free value, use in history, jobs, block duration, node count history, everything you have. Node bills count, node offline, plugins, project count value, all those values it was shown. Okay. So the same can be visualized here. And also this might be a new container, right? So it should start again because we launched a new container. Skip this. Because it's all new, right? So even new connection you should make because we terminated the old containers. So for Prometheus, add the new data source. Put this Prometheus URL. Test the connection. If it is working fine, go to dashboards. Create a dashboard again, new dashboard. So here add visualization. Prometheus as a data source. Now here you may choose the metrics whichever you want. Let's say I want to search for, or else you can open here. I want to search Jenkins. Let's say Jenkins job count value. Okay, run the query. Right, it's showing as such. The apt one would be here as a stack, right? Or else as a table format. You can see here all the jobs, last 6 hours, or else I just need last 5 table view. If you don't want table view, you can see like this, right? Or else I just want to see it as a stack. Right, that's about the stack. You can customize it anyhow. Of course, here it's not applicable. Let's suppose it's a memory, CPU consumption. You can also customize them here. There'll be cell mappings. Here, panel options, value options. You can customize to any level. Colors you can change, text size, formats. You can do a lot many. See, you can set some threshold. Let's suppose if it is 9 means it should be showing like, okay, base means the you can set those as well as overrides. Cell overrides will be there. Text standard data value mappings. Yeah. Value mapping means if it is 9 means it should show like, okay, of course, consider it like a memory consumption. It should be in green. Let's suppose if the value is like 10, exact 10, then it should be warning kind of. And the color should be red. You can do that as well. So instead of value, it is showing like it's okay. Am I making sense? Interesting, isn't it? These kind of dashboards you can create, save them to visualize them. Save it in the new dashboard. Or you can drag and put it at any place. Of course, it is all empty, so it was on the beginning. Otherwise, you can just adjust if you have multiple panels. Any questions from anyone? So now our Prometheus is also monitoring this Jenkins server. These are all the metrics. You can see it will explain what this metric does. Help is there, type of the metric is there. See memory pools, job, waiting duration, everything. Any questions from anyone?
Priti, one doubt.
Mm.
As a DevOps engineer, what is our responsibility in Prometheus and with Grafana and day-to-day activity?
See, you have to monitor, let's suppose you deployed some pods on a cluster on the worker node. Your pod is not working. It's saying crash loop back off. You see the error and see that it was a memory is not enough or else there's no CPU. How do you check those resources? It's your job to see your pods are running, right? Or else
Yes.
in Jenkins server you are running CI/CD pipeline. Let's say CI/CD pipeline is breaking. The server is out of memory. Not only always about memory, it could be any other health checks, any other status, right?
We will get the alert, right? I think that log.
You can configure the alerts. There will be something like alerts. Here you can configure the alerts. Like when you want to alert, you can configure them. And Alert Manager is another application available which can be integrated with Prometheus. And once you have that SMTP server configured, yes, it can trigger the alerts. That's
And
how you
also we have inbuilt Jenkins alert, right? For every
Jenkins notifications. Yes, you have Jenkins email notifications as well. Yeah.
okay. So basically, this is a dashboard to monitor entire our DevOps.
Yeah, our infrastructure. If something is going wrong, you have made everything automated, CI/CD pipeline is running, but you need a tool to monitor for your deployments or for your pipelines to work effectively without any interruptions, without any disruptions, right? So that's where this monitoring tool comes in. So this is about monitoring Prometheus and the containers. We can also monitor another Linux server, like there might be another EC2 instance or a remote Linux server. Your Prometheus have to monitor it, how to do that, and how to install a plugin. Those things we shall see in the next class. Any more questions
How
from
traditional way we are managing that Prometheus?
how?
Traditional way. Traditional way I mean in real time they will deploy as a pod or in
So if you
on-premise they
want to
will deploy.
monitor a Kubernetes cluster, we'll deploy them as pods. We have seen that, right? With Helm chart, we have installed Prometheus, and by default, once Prometheus, it was monitoring all the cluster resources.
Yes.
Through Helm chart, you can install that Prometheus on the cluster. Or else if you want to monitor any other resources, this is how you can, as a container you can do, or else directly you can install Prometheus by downloading the source.
Is based on our setup.
Our requirement, anything is fine. But on cluster, Kubernetes cluster, definitely we'll be installing with Helm chart because writing those custom configurations would be difficult. So many components would be there.
Yes.
Preeti, do we have a class tomorrow?
Tomorrow we shall not have a class. We'll have a
Okay.
class on Monday.
Okay. Still, how many topics are left now?
This
We
Prometheus,
cover.
we need one more session for monitoring our
Okay.
remote server. And then
Okay.
that's on Monday. And then AWS code commit, code build, code deploy, code pipeline. Those are, with that, we'll create a pipeline, which may take another 2 days.
2 days. Okay.
So maybe 3 sessions more.
3 sessions.
Any other questions you have? See, if you have any other questions, you can also note it down. Okay, we can discuss in the coming up classes. Even the sessions are completed, like training is completed also, you are welcome with your questions.
Sure.
But do practice, go through them definitely. Your WhatsApp group, everything will be there. You will still have your support.
Preeti, and also I registered, you remember, that day-to-day activity and roles and responsibility. You said
Okay.
take it on separate
Yeah,
session.
see, actually by now you might have understood the roles and responsibilities what you do, but if you want, we can discuss as a separate topic so that you will get a clarity on it. At the end of the class, we shall do it. Yeah, end of the course.
Yes. Okay. Thank you.
See, nothing but everyday daily task would be generally if it is a new pipeline, let's say we have to create there's a new repository, new API. You have to create a new pipeline. That might be implementation task. Like you have to create a Jenkins pipeline end to end. In that, you may have to create this manifest files and deploy some service, let's say, or deploy some application. That might be the task. Or else, sometimes what happens, existing pipelines might be broken. You have to troubleshoot and fix them. That could be the task, daily task, right? Majority of the times we'll have to fix the pipeline issues, pipeline errors. There might be version incompatibility, or else pipelines might be broken because of, like I said, memory issues, or else whatever it is. First, we need to troubleshoot those and fix them. Those would be the task. Creating new pipelines would be the task. Or else, let's say you are in the implement. There might be two things: DevOps implementation, or else DevOps support. DevOps implementation means we call them as developers, means a developer team and support team. Both are DevOps team only. Developer means not who write the code. Developer means what they mean is who write manifest files and all, and who make the deployments. Okay, that will be a one team who will make the deployments. There will be a support team. If something is broken or if this deployment is not working, they will do the fixes. That is support team. It depends. Not that every company should have two teams, one for developer kind of and the one support, but maybe it could be that way. So the support team will keep on fixing the errors which comes up. Implementation, actual implementation, like creating new pipelines, creating deployments might be done by the developer team. Developer team is nothing but DevOps team who make the actual deployments and implementations. Or else, let's say you want to create a new cluster. So that DevOps team, implementation team will do. And okay, cluster is created, they deployed something, but pods are not running. That will go to support team. Anyway, we will discuss that again separately. But generally, yeah, that's how it is. These are all the tasks, but depends on whether you are doing implementation on support, depends on which team you are in, or else there might be only one team who will do everything. It all depends on the organization, the project, and so on. We'll have a discussion again at the end of the course in more detail.
Yeah, and also see, not only DevOps, if we have a Kubernetes that setup environment, we need how much we need to involve in the Kubernetes. Is a full and full support for DevOps team, or is a separate ops team will be there for support?
Again, it depends on the organization and the projects. Because see, everything, it depends on the organization. There is no strict rule that this is how it should. Particularly for DevOps, it's very ad hoc. Everything is changing. Every organization is following its own way of doing the things. So it all depends again on the organization. But what are the different ways it could be? Is one of the ways could be there might be again two teams. You will be selected for DevOps role only, but Kubernetes is a priority. This particular Kubernetes team, Kubernetes admin team and Kubernetes developer team. Kubernetes admin team means they will create the clusters, they will take care of the backups, everything of the cluster. Okay, they'll manage the cluster. Developer team will make the deployments. Developer team means DevOps development team. They will make the deployments by writing the manifest files. And means you may master writing the manifest files, application level support, right? Other thing is admin support for EKS cluster. That's where you have two certifications, CCAD and CKA. A is like certified Kubernetes application developer. Application developer means, okay, there is some PHP application, you want to deploy it. You will write the manifest files, okay, you will create all the deployment objects, you will create the config map, secrets, whatever this PHP-DB application needs. If required a Helm chart, you will do all of this and deploy it through the CI/CD pipeline. That's of course, CI/CD pipeline is different. I'm talking about Kubernetes. So it comes under certified Kubernetes application developer. Or else there might be, then okay, this development team is working on this. Then who will create the cluster? Who will check the backups, volumes of the cluster? Maybe remote volumes might be there. Backup of the cluster is needed. Cluster upgrades should happen, right? HCD should be taken care by. All of this separate team. That's where CKA comes in, Certified Kubernetes Admin. Two certification goes in. Basically, Kubernetes Admin team, Kubernetes developer team. In huge organizations, it might be the case. In smaller companies, only one team. Also, no separate team for Kubernetes management. Everything will be done by the same DevOps team. So it depends. Let's say there's a job description, you are called for an interview. Job description tells whether they were looking for DevOps person. DevOps person means he has to work on deployments, Jenkins pipelines, monitoring, everything. Or else they want a dedicated Kubernetes professional. That's where they look for certifications, preferably. Because they only need, they don't want this team to work on CI/CD and all. Of course, they should have knowledge, definitely. But a specific, a dedicated team if they are looking for. Maybe they may have critical applications, more applications of Kubernetes. A separate Kubernetes development team might be there. So your job description explains you everything. And various companies will have their own way of implementing or managing these things. Hope that helps you to a certain extent.
Yes. Yeah. Thank you.
In volumes, we have learned something like volumes and volume claims.
Volume claims. Yeah.
I told you like claims and pods will be taken care by developer. Developer here is Kubernetes developer. Because I'm a CCAD professional, I work on application, I work on the requirements for the application through config map, secrets, claims and all. I'll not be bothered about volumes. Of course, I'll configure the volume, but how volumes are stored, where they were stored, whether backup on another team. But of course, it is irrespective, even though that's just a certification of your interest. But you might be asked to work on everything or else a particular thing. It all again depends. But you should know overall, entire flow you should know. You can't say, okay, I'm an application developer, I don't do admin tasks. No. You should decide that either when you attend the interview or when you select the role. After selecting the role, you don't have any such excuses.
And is some basic idea I need. How much the OpenShift now in market?
OpenShift,
Red Hat.
like is it for Vulnerability check of images?
No. This is like Kubernetes alternative from Red Hat.
OpenStack or
OpenShift.
OpenShift? Okay.
Yeah.
OpenShift. See, that is also provides you container orchestration, but a product from different vendor.
From Red Hat, yeah.
A container orchestration tool only. But if you know Kubernetes, definitely you can work on anything else. And Kubernetes is more used than anything else. I don't have specific or particular experience with OpenShift, but yeah, it would be similar to Kubernetes, I believe. Container orchestrator.
Yeah. Thanks.
All right then. Thank you, everyone. See you all tomorrow. I mean, on Monday. Thank you all. Bye. Have a good day and happy weekend.
Happy weekend.
Thank you all.